The net rate of what?
Of that step.
Of what step?
RH
It's not the net rate of any step. When I apply PSSA, it has nothing to do with a single step. In fact, it's almost always going to have multiple steps.
It's the forward and backwards.
Yes, it's the production and generation of what? RHAD in this case. So you treat these as if they're totally different species. So RHAD. So what forms RHAD? The first reaction written in the forward direction, so that's Ka times the pressure of RH. What consumes RHAD? Minus Kd times what? The concentration of RHAD. Anything else? Two different steps. I'm on this step still. So that was Kd. That was the reverse of the first reaction. And then, yeah, the forward of the second reaction consumes it. Yeah, so it subtracts K, now C, RHAD times what? What squared? Yeah, I'm going to go ahead and just put in L squared. But yeah, either one is fine, just as long as you remember that you can later make that substitution. I know that's crowded, but. Okay, so what do we then do with that? What is that equal to? Okay, so I can set that equal to 0 because of PSSA. And then what can I do with it? Solve for what I don't want, which is RHAD. And that's Ka, pressure of RH, divided by two terms, Kd plus Kc, and then the concentration of total sites squared. And now what do I do with that? Plug it into here, right? So what do I get? I just had that was just R. Ka, Kc, pressure of RH, concentration of total sites squared, divided by Kd plus Kc times concentration of total sites squared. So what is K effective?
KC L squared.
No.
Oh, yeah.
Over the entire denominator. Okay, so now I'll ask you a question that we had on exam 1. Under what mathematical expression is step 1 quasi-equilibrium? I want to write down an inequality. I'll give you a hint. Now tell me what to put on the left and what to put on the right in order for step 1 to be quasi-equilibrium.
KC L squared.
I'm writing this down on the left.
KD on the left.
Kd on the left.
KC L squared on the right.
I have no idea. Is he right? Yes, he is. Because if this goes away, then what am I left with? Ka, Kc, Prh, L squared divided by Kd. Right? And what is this? I know it's not defined here, but it's the equilibrium constant for that step, which I'm just going to call A. And so that means that the rate constants for that step aren't in my equation. That means that I'm quasi-equilibrated. Another way you can think about it is if I would have started with that assumption, That's what I would have ended up with. Right? If I would have started with the assumption of step 1 is quasi-equilibrated, what rate equation would I have ended up with? That one right there. So that's why you mentioned, like, is PSSA the same as quasi-equilibration? No. Yeah. Very, very different. Only under certain conditions is that the case. Okay, yeah, and I guess the hint there to do PSSA was that the adsorbed RH molecule is a short-lived intermediate. I think I would rather just tell you guys, do not use quasi-equilibrated. You know, this step is not quasi-equilibrated. If I tell you a step's not quasi-equilibrated, it doesn't mean it's rate determining. It just means it's not quasi-equilibrated. Okay, let's do one more thing here. Okay, if this is true, then what is the rate determining step when that is true? Second one. Okay, what's the rate determining step when that's not true? If that's the rate equation, what's the rate determining step? Who thinks the first one? Who thinks the second one? Who doesn't like raising their hand in class? You're all liars. You just Which rate constants are in here? Are rate constants in here for both equations? Yes. Are they in here in any way that I could replace them with a single equilibrium constant and it would remove all the rate equation, all the rate constants? I can replace, for example, I can replace KD is equal to forward or reverse. Is that right? It's the inverse of that? See? I can do that. I can do that without any problem. And that way KD is not in there. But if I do that, does that mean that the KA's cancel out? No, right? So in other words, both steps are rate determining. Yeah.
Well, since you have to insert the L star instead of in terms of, sorry, if L squared is equal to star squared, isn't it all constants except for the pressure of the ethylene?
Yeah, they're all constants, but the question for what step is rate determining has nothing to do with what's constant. The question that you're answering is what is inside K effective. And in fact, everything you just mentioned was inside K effective. But what I asked was which step is rate determining? Well, which step's rate equation, rate constants show up in K effective? All of them. And not because I failed to simplify, right? It wasn't because I was being lazy and didn't get rid of Ka over Kd. It's because they're all relevant. All of the steps in this equation are will affect the rate. Now, of course, that's not true if I'm at one of my limiting conditions, right? For example, this limiting condition, that no longer is the case. But under that condition where those two terms are roughly equal, both steps are rate determining. I think that might have been the other hint within this, is that he never told you what the rate limiting step was. So for you to assume it was one or the other might have been a mistake. Yeah.
So to differentiate between PSSA and quasi-equilibrated,
Right.
PSSA just says one of the intermediates concentration does not change throughout the reaction, even if it's in multiple reactions.
Exactly. PSSA means that I can do that.
Okay. And then quasi is basically one of the equilibriums and concentrations are changing so slowly that they look like they're in equilibrium. Because if it's being consumed at such a slow rate, then the reaction before has
Yes.
to be pretty much.
Yeah. But you know, they're not. They don't have to change with time at all, and they can be quasi-equilibrated.
Right.
So that doesn't, just because something is quasi-equilibrated doesn't mean that it's slowly changing with time. It doesn't have to be. It can be exactly zero. At steady state, it's zero.
So
What
it's
it means is that the forward and reverse reaction happen a lot
Okay.
compared to whatever the forward rate of the rate determining step is.
And the rate determining.
But mathematically, quasi-equilibrium just means I can write down the definition for the equilibrium constant and use that because it's valid.
Right.
like saying.
Now that's always valid, but the concentrations that you put on the right-hand side are only true at equilibrium. So this is just saying that you're at equilibrium for that step, and you can write down the equilibrium constant is equal to that.
And the rate determining step, is that like one of the slower steps relative to all the other steps in reaction?
The rate determining step, if you imagine adding up the number of times it happens in the forward direction and in the reverse direction, it doesn't happen very often. It happens without a lot of frequency. But the net rate for that step is the same as the net rate of every other step if you're at steady state. And you often are. I mean, not all reactions are at steady state. Batch reactions are not at steady state. The CSTR is, the PFR is. And so under those conditions, the net rate of each reaction is identical. Otherwise, you're not at steady state, right? You're accumulating something on the surface. Yes?
If you could post the problem statement for this question.
Yes. Well, let's make sure we finish it. I know we're close to running out of time, so. You guys can leave. I won't be offended. The rate of ethane dissociative chemisorption. All right, so the rate. The rate decreases with increasing temperature. Is this mechanism, or is this observation, sorry, consistent with the mechanism suggested in part B or part C? And I'll remind you that part B was RH plus 2 star irreversibly goes to R star plus H star. And part C was that over there. This is part C. Yeah. The rate of dissociative chemisorption is found to decrease with increasing temperature. Is this observation consistent with the mechanism suggested in part B or part C? And of course it has the whole explain your reasoning to receive credit. So which one? And how do we know?